Welcome to The Explainer. Today, we are diving headfirst into a massive climate puzzle, one that connects the huge Pacific Ocean to the fate of more than 1 billion people. It's a story that's got everything: a powerful weather engine, a long-distance relationship, and a genuine mystery that had scientists scratching their heads for years. So let's get into it.
Okay, so first things first, let's set the scene. You gotta understand, the Indian summer monsoon isn't just a bit of rain. No, it's the absolute lifeblood of the subcontinent. We're talking about 70 to 90% of India's entire annual rainfall, all delivered between June and September. It pretty much dictates everything, from what farmers can grow to how much water's in the reservoirs, all the way up to the nation's whole economy. When it goes wrong, the consequences are just enormous.
And that right there brings us to our central mystery. See, there's a well-known troublemaker in the world of weather, a powerful climate event called El Niño, and historically, it's got this nasty habit of wrecking India's monsoons. So in 1997, one of the strongest El Niños ever recorded fired up. All the signs were pointing to an absolute disaster. Everyone was bracing for the worst, and then nothing. The monsoon was, well, it was normal. So the big question is, why? What on earth saved India that year?
All right, to crack this case, we have to get to know our main suspect. And believe it or not, it all starts thousands of miles away in the Pacific Ocean, with a phenomenon called ENSO.
ENSO. It stands for the El Niño Southern Oscillation, and it is without a doubt the planet's most powerful climate pattern. At its heart, you can think of it like a massive amount of warm water sloshing back and forth across the Pacific, almost like in a giant bathtub. And this isn't some one-off storm. It's a fundamental shift in the entire ocean and atmosphere system that can last for months on end.
Now, ENSO basically has 3 different personalities. First, you've got El Niño. That's the warm phase, and it usually means bad news for India's monsoon. Then there's its colder twin, La Niña, which typically boosts the monsoon rains. And finally, you have the neutral phase, when things are pretty much average. But for our mystery, El Niño is the one we're watching. He's our prime suspect.
So how does all this actually work? Well, the engine driving the whole thing is called the Walker circulation. So normally you get this huge pool of warm water that piles up in the western Pacific. All that warm, moist air rises up, creating a ton of rain over there. That air then travels east, way up high, cools down, and sinks over the colder waters in the eastern Pacific. Then the trade winds blow it all back to the west, and boom, you have a giant atmospheric conveyor belt. That's how it's supposed to work.
Okay, but here's the kicker. This engine doesn't just keep its effects in the Pacific. It has what scientists call a teleconnection. Think of it like a climate long-distance call. It's an influence that can reach across the entire globe and directly mess with the weather in India. So here's how the crime goes down. During an El Niño, that big pool of warm water sloshes eastward, and it drags the entire Walker circulation along with it. So now, the sinking end of that loop, the part with dry, stable air, gets shoved right over the Indian subcontinent. That sinking air basically puts a giant invisible lid on the atmosphere, stopping those vital monsoon clouds from ever forming. The result? A whole lot less rain.
And the evidence against El Niño? The rap sheet is long. Historically, about half of all El Niño years have resulted in drought in India. I mean, just look at this track record. 2002, a 19% rainfall deficit. 2015 brought crop failures and soaring food prices. And 2009? Well, 2009 was really bad.
Minus 22%. In 2009, the monsoon saw a staggering 22% rainfall deficit. It was one of the worst monsoon failures in decades. So you see the kind of firepower we're dealing with. When El Niño hits, it hits hard. Which makes what didn't happen in 1997 all the more baffling. It just doesn't add up.
But what if our main suspect didn't act alone? The climate system, you see, is an incredibly complex place. And in 1997, there were a few other players on the field. It's time we met the accomplices.
Okay, this is it. This is the smoking gun that solves the mystery. On the left, you see a typical El Niño year. It causes that sinking air over India, and the result is drought. But on the right, you have 1997. You still have El Niño trying to cause a drought, but it was being fought off, countered by another force that was making air rise. Think of it like a climatic tug-of-war. That accomplice has a name, the Indian Ocean Dipole, or IOD.
So what is this IOD thing? You can basically think of it as the Indian Ocean's own version of El Niño. It's a seesaw of ocean temperatures. And in 1997, it was in a positive phase. That meant the western part of the Indian Ocean got unusually warm. That warm water created a rain-making machine right on India's doorstep,
and that machine was strong enough to completely cancel out El Niño's drought-making effects. It literally saved the monsoon.
And if you thought that was complicated, hold on, because there's yet another layer, the Madden-Julian Oscillation, or MJO. The simplest way to think about it is as a massive pulse of clouds and rain that travels around the globe every month or two. If that pulse is in the right place at the right time, it can give the monsoon an extra little push. So it's not a one-on-one fight. It's more like a chaotic royal rumble of different climate patterns.
But here's the final twist in the tale. Just when we think we figured it all out, it turns out the rules themselves are changing. The fundamental connection between El Niño and the Indian monsoon, it's not set in stone, it's in flux.
You see, when scientists dug into over a century of data, they found the story plays out in 3 acts. From 1901 to 1940, the link got stronger. Then, from the 40s to 1980, things were stable, predictable, and El Niño almost always meant a bad monsoon. But then, starting around 1981, things started to get weird. The connection began to weaken and shift. And this change isn't happening everywhere at once. It's like we're seeing a tale of 3 different Indias now. In the south, the relationship is pretty much business as usual. But in North India, the link has actually gotten stronger. Rainfall there is more tied to El Niño than ever. The biggest shocker, though, is in central India, the agricultural heartland. There, the connection has become so weak it's almost gone. Local weather patterns are now calling the shots.
Climate scientist Roxy Matthew Calls sums it up perfectly. He says this makes forecasting incredibly difficult. You can't just use one rule for the whole country anymore. Basically, the old playbook for predicting the monsoon, especially for the country's breadbasket, is kind of out the window, and that's a huge problem.
And that brings us to the most important point of all. You might be thinking, this is all fascinating science, but why does it really matter? Well, because when you're trying to forecast the monsoon, you're not just forecasting the weather. In a very real sense, you are forecasting a nation's fortune.
I mean, the stakes could not be higher. When the monsoon fails, it sets off a chain reaction. Crops fail, threatening the food security of millions. Reservoirs run dry, leading to severe water shortages. The price of food goes up, hitting every single person's wallet. There's less water for hydropower, which impacts the energy supply. And ultimately, it can actually slow down the entire country's economic growth. Every single piece of this puzzle matters.
So, we cracked the case of 1997. But in doing so, we've uncovered a much bigger, more urgent puzzle. We've learned that El Niño isn't the only player on the board, and that the board itself is changing under our feet. The question that's left for everyone, forecasters, policymakers, and farmers, is a critical one. As these patterns keep shifting and the old rules break, can we figure out the monsoon's next move before it's too late?